Hey everyone, in today's video we're going to have a look at scales of production. So what you need to know is what the different scales of types of production are. So there's things like one-off or bespoke, batch, mass production, unit production systems, QRM and vertical in-house production. So first of all, to begin with, the whole idea of the term manufacturing, what that actually sort of like in its most basic form is essentially how do companies take the raw materials of something and then turn that into a goods or a product that is then sold to consumers at the end of it. So the term manufacturing essentially just describes that whole process. And obviously, depending on what the product you're manufacturing is, depends on the type of manufacturing that you'll do. So when it comes to manufacturing, there are a few different requirements a company needs to be able to sort out before they can actually set up and start producing what they need to do. So for some things, there'll be specialist buildings or places of work that are required. That may be certain kinds of equipment or things like that. Organisation of people. So actually having people there trained, knowing what they need to do. Organisation of your tools and equipment to have everything set up, having everything you need. Any health and safety considerations. Obviously, depending on where you are in the world, there'll be some different health and safety considerations. Obviously, if you know, there's things like sweatshops where safety clearly isn't a very high priority, whereas if you're manufacturing in Europe, there are very strict health and safety regulations that to be considered. Communication systems, I mean, you can argue that possibly communication is the single most important part of manufacturing, because how do you keep everyone organised and keep everyone knowing what they need to do if you're not communicating effectively? And then basically some efficient working methods, so understanding, okay, here's the thing we need to do, what's the best way of going about doing it? And that's sort of what we're going to go over in the next few slides. So the first one is one-off production, also known as bespoke. So typically for this, it's going to be a very highly specialist company or person. The person doing it, it'll be a small team that does it basically. So one or two workers, and they're going to be highly skilled in what they're doing because they're only going to do that one thing. There will be this constant communication with the client because you've gone to this person to make whatever you need to make. So whether that is like a wedding dress or a handmade piece of furniture, I think it's not something you're just buying off Amazon or you're buying in a shop. You're getting this built specifically for you, so it needs to be for you. Otherwise, you're not going to pay for it. So we've talked about user-centered design in theory before. So there'll be that constant communication with the client to make sure that they're producing what you want to produce. There will be the company will specialize in that particular thing. So if like wedding cakes, that baker won't be a general baker. They'll just do specific wedding cakes. There'll be things like furniture. So that company will only make specialist furniture. Engineers, musical instruments, so on. So you wouldn't go to a generalist. There's the difference between being a generalist that can sort of make an okay model of pretty much everything in that sort of field, or a specialist that specialises in that one specific thing. Specialist materials are often required. So you wouldn't, if you get like a piece of furniture made, you wouldn't be using things like MDF or chipboard. You'd be using higher quality equipment, higher quality materials. Because of all of that, because you're paying for this highly skilled person and this good quality material, the final product's going to be a lot more expensive. What the old saying obviously is that you get what you pay for. You're paying for this one-off bespoke thing. You'd expect the price to be high anyway. And because of that, obviously, you're going to get a high quality product at the end of it. So examples of that might be things like having anything handmade that you'd get, so like bits of furniture, that sort of thing, wedding dresses, prototyping. There are certain things like medical professions or aerospace and those things where they only ever make like one or two of them. So your next one will be batch production. So this is the first time we start seeing a bit of what's called a production line. So batch production is where you're making items that are identical and there's going to be a small quantity of them. So a batch can be anything from 2 to say like 50 or 100. A batch can be quite a big batch, but it just means you're not going to constantly just make that one item the whole time. You'll switch to another item. So you have your production line. So each worker will have their one task that they're doing. Maybe they can do one or two of the tasks. The workers are semi-skilled or unskilled, so they're trained, but they're not like highly qualified, highly specialist like bespoke. So the workers need to switch from one part of the production line to another. So that's where you have like flexible working. So basically, once you swap to another batch of another product, they need to be able to do that one as well. Productions can be changed quickly depending on what you need to do. So basically, if you take like Greg's or something like that, they don't just make sausage rolls all day. They'll make steak bakes, they'll make sandwiches, they'll make donuts. So you need to be able to change up what you're doing several times a day to be able to make lots and lots of different little bits. Typically, a lot of individual parts will be brought in from other companies, so they won't necessarily make all of every single part. So by that we mean things like bought-in components like bolts, screws, pins, those sorts of things. There's no sense because it will cost them more money to set up to make those parts. It's just easier to buy those parts in. And typically with batch production, if you take like the bakers, for example, they'll make certain parts and then they'll move on. But it also may be, for example, games or something where they'll make a batch of it and they'll move on to the next one, or cars or wherever it may be. So really, most common examples would be bits of furniture, electrical goods, clothing, newspapers, and that type of thing. So next you got mass production. So this is where you got a full automated production line. So each worker completes one task and passes it on to the next person. So typically here you've got semi-skilled or unskilled workers. The cost of setting this up is quite high because you're going to have a lot of specialist custom-made equipment for it. And then you'll have parts brought in again like we did before with bought-in components. And here you're going to make things like mass-produced clothing, bikes, mobile phones, things that you see a lot of. Similar to mass production, you've then got continuous production. So the only difference really with mass production and continuous production is continuous production doesn't stop. So they're only going to make one thing. They're never going to swap between multiple products. But essentially once production starts up, it just never stops until something happens and you have to actually just stop completely. So it'll be semi-automated, so there will be some machinery that's involved along the process as well. You're going to have a mixture of skilled and unskilled workers depending on what the sort of thing you're going to do is. There is a high level of investment, similar to mass production, because you've got this special equipment setting up. You will have what's called quality control checks at every step. So we will do a theory on quality control and quality assurance, which is essentially how do they make sure that because you're making thousands and thousands of the same product, how do you make sure they're all made correctly? So it's checks that you'll have throughout each stage to make sure you're producing something nice. So the kind of products you might have are some cars. Now, cars are quite a generic term because obviously you've got some much more expensive cars where they'll make batches of them or they might make one of them. But if you're talking about cars that you see a lot of, or certain car parts, petrol or oil products, certain kinds of food products, paper products, washing powder, certain chemicals where you just need loads and loads of them, and things like biro pens and that sort of thing. So next you got what's called unit production systems. So this is mainly used in textiles, and what you've got, so if you look at the picture on the right, essentially your worker is going to stay at their station with their machine, and all you'll have basically is garments, so textile clothing, that sort of thing, will all come from overhead like rails to come to the person. So basically the whole idea being that you don't need someone to get up and run to go and get their equipment to come back. You don't need to hire a different person to sort of go in between workers to give them equipment. So it speeds up the whole process while still keeping the good quality because people are just focused on doing what they need to do. Next you've got modular or self-production, goes by the same name. So this is where you're going to have sort of a space set up with multiple different machines. So you have it's typically going to be CNC machinery, which hopefully you know stands for computer numerical control machinery. So they'll all be programmed to do a few different jobs in sequence. So basically there's not going to be very much human interaction. Obviously the human interaction will be programming the actual machinery itself, but essentially it might be things like CNC lathes, mills, drills, grinders, lasers, printers, those sorts of things. But basically machine one will do its job and then a robotic arm will take that material and move it to the next machine and that'll do the next job, and the robot arm will take it to the next machine and that'll do the next job. So it's all inside this little cell or this little module. So you've got 4 or 5 different machines and the material just pass between each one of those machines to make the next part, to make your final finished product. Now typically if the machines are quite close together, robotic arms will move the material between each part, because robotic arms can do quite a lot if you've got different kinds of grip methods to actually physically hold the product, because they can hold very, very heavy products that humans can't, basically. Because if you've got quite a heavy like metal product and trying to get a human worker to try and transfer that to another machine, one, you got risk of injury, and two, they might do it wrong. So if you can have like automated robotic arms, will take care of that for you as well. If they're a little bit further apart, the machines, typically you could have automated, what's the word? Automated like vehicles basically that will transfer it to machines depending on what it is. So next we're going to have a look at like quick response manufacturing. So the whole aim of quick response manufacturing is to make the lead time as short as possible. So the lead time is basically how long does it take from when I've ordered something, how long till I can have it. So if you think like Amazon, well, I mean, we're kind of spoilt with Amazon now, as you press buy now and pretty much everyone's like, well, why is the doorbell not rung yet? Where's my thing? But I mean, with Amazon Prime, you buy something and then the next day it's here. So the lead time is essentially from when I've ordered it, when can I have it? Because in this modern society, we're very, very impatient. So with quick response manufacturing, there's a couple of things involved in that to sort of make that a little bit more doable. So you've got vertical in-house production. So before, we've talked about some of the methods where companies had bought-in components where they bring in, it's not worth their time making bolts and screws and pins and certain like generic things because they've got a setup for it. They've got to pay all that investment to make it in-house. But if you're a big company and you're doing it, sometimes it is worth doing that. And once you start producing those parts in your own company, that's what vertical in-house production is. It means basically you're not relying on other companies that might be out of stock. They might go out of business. So it does mean you've got control over the whole process. So it's expensive to set up because you've got to set up a whole other part of a factory to do that manufacturing. But once you've got it set up, you're in complete control of everything that you've got. You've also then got what's called just-in-time. Now you may have come across this if you did business studies at GCSE or you do business studies now. So this is the idea that typically what happens when you're not using a just-in-time method is companies make a product, or they make loads and loads of products and they put them into storage and then they ship them out to shops and they stay in warehouses and factories. Just in time is the idea that they'll only manufacture it once it's been ordered. So rather than having like a stockpile of products, they only start to make it once they know it's going to be sold. The benefit of that is that you don't have to start paying for like storage. So like you don't have to buy more warehouse space to store everything. What can happen if you're storing things for too long is it can become obsolete. So if you're doing like electronic products, it might be that you've got something storing for 6 months and electronics moves so quickly that that's not even, you've not sold it yet, but it's not even, no one's going to want it anymore because the latest things come out. It may be the same with things like football shirts, for example. You make so many of them and then the next season comes along and then no one wants last season's shirt anymore. So it's sort of wasted and ends up getting chucked away. So it's a much better way of reducing waste. The problem that you may come into is that certain things are out of your control because obviously you're just making it as it's ordered. So an order will come in and then you will contact all your suppliers. Normally it'll be automated. You don't physically go around and call everyone up. But so say someone said, okay, I want one of your products. Then all of the suppliers for all the parts you need get contacted for them to ship to you. Now, if it's working perfectly, those parts come just as you need them. You make it all, you got your finished product done perfectly. But if there's like a disruption in the delivery chain, so think things like the delivery driver shortage that we've had in the UK recently, think about things like COVID, all these sorts of things could disrupt that the delivery, which means your product's not going to get built on time, which means your customer's not going to be happy, so they might end up going elsewhere. So there are big benefits to it, but there are also, because you're not in complete control at all times, you're relying on other people. So there's always that risk that it might not be as smooth a process as you want it to be. And if you're like a big high-end company, you want that control. Next, we've got flexible manufacturing systems. So one of the big examples, and they use it in the book quite a lot, is Toyota for this. But the idea is that they use the modular or cell production that we talked about before with like CNC machinery doing a lot of the work. But the idea being is that you can change the product quickly depending on the demand. So if we take like Toyota, for example, they might be making a certain model because there's been a big demand for that certain model. And then suddenly, next day, is a different model's needed. So the idea being that you should be able to change all the parts you need really quickly. Now, there's this thing called single minute exchange dies. Now, that term, single minute exchange dies, basically being it should take you less than 10 minutes to change the parts on the machines to make the other product that you need. So that's what it refers to, is it should be single minute, so 9 minutes or less to change the parts to then make a whole different product again. And apparently Toyota, they were the ones that sort of pioneered this whole idea, and they can do that, and they can jump between making different models of cars depending on the amount of orders they've had, and it's still going very strong to this day, actually. So when we talked before about vertical in-house production and buying, making everything in-house, the opposite of that is getting bought in components. Now, components is a term given basically to parts that fit into different elements of the design. They're all pretty much the same, depending on what it is. And some companies decide it's worth buying them in. Some people decide it's worth making them. It depends on what scale of a company you are. But I just want to go through some examples of like standardized components and what that term actually means. So the original like breakthrough of the standardized component was the British Whitworth screw in 1841. So basically means that when you buy a screw, you're getting that same type of screw all the time. So the thread's always going to be the same. So it's always going to meet the size hole that you need or the size thread that you need. The reason why that's helpful is that before then, if you're trying to replace certain parts, it's impossible because each company's making their own different screws or their own different threads, and you're just never going to get replacement parts. As time's gone on, there's an understanding between a lot of countries and a lot of countries to sort of like standardize what we're doing. So typically there's a metric international standards organization. So the ISO, the International Standards Organization, has basically adopted it by most companies so that everyone's agreed to use this size screw or this size bolt. So it just means it's a lot easier that everyone's using the same little parts and things can be replaced and fixed really, really easily. That is except, of course, USA and Canada that still stick with their imperial system. I won't go too much into that, but the imperial system is dumb. There's a reason why pretty much everyone uses the metric system. The more people that agree to use the same system, the easier it is, but obviously America and Canada have to be America and Canada. So common kind of standard components that are pretty much the same wherever you go is things like tyres, plumbing fittings, door locks, audio connectors, batteries, fuses, fitted kitchen units, printer cartridges, pen refills, memory cards. That's not an exhaustive list. There are so many things where it's just you don't get different sizes and things. They're all just standard sizes. So it doesn't matter who you buy it from, you're going to get that size of a thing. So bought-in components. So this is, as we said before, it's just easier for a lot of companies to just buy those parts in because otherwise you're going to have to set up another part of your factory to make all those individually, where you could just buy 10,000 screws or 10,000 fittings or whatever it is that you may need. You can get something called sub-assembly. So this might be if you have things like hydraulic valves or gearboxes or electric motors, where what you essentially do is you buy in like a kit that has all the parts that can then be manufactured. So you might get like the CAD files for it so that you can then integrate and produce it all yourself. So you buy it in bulk, so it's a lot cheaper. It's a lot more consistent. It's time saved, but it just means that it's one less thing for you to have to worry about as a company. What can happen, and what actually interestingly has been happening a little bit, or will soon be happening with Apple as they're forced to do certain things, is when standards change, things come what's called obsolete. So what that means is obsolete means things will no longer don't make parts for it anymore, so you can't really replace it or fix it. So things like Apple get rid of their headset, the socket. You are all probably too young to know life before HDMI for your consoles and TVs and that sort of thing, but there used to be something called a SCART cable. Windows 10 causing compatibility issues on pretty much every bit of software going. New printers not accepting old cartridges. No disk drives, things like floppy disks, all these sort of things. So once, because standards do change over time anyway, and this slowly things are faded out. But there are some companies that try, like Apple are terrible at it. There is certain like ongoing legal things at the minute where Apple is sort of being forced to use the same sort of charging port as Androids and everyone else, because then everyone's got the same charger and you can't start charging extra for it and then change it later. So just make sure you understand the whole idea is once standards change, like I don't imagine you've probably got anything that's got SCART cables on it anymore unless you've got some really old electronics knocking about. Essentially it was the cables that had like a white, red and yellow socket that would go into the back of a quite fat adapter that would then go into your TV. But obviously as new technology comes in, standards change and we all agree, and then slowly we fade those out as well. Okay, so last thing is, can you have a look at those questions for me? Use your notes, use your textbook, and then if you've got any questions, please let me know.